Good evening, DGF fifth graders. Welcome to Chapter 8, Lesson 20 today, and we will be on page 403 in your math activity book. So go ahead and turn your book to that, and please follow along as we do these. It will make the Think Central question much easier, and you'll probably have a lot fewer questions if you follow along and actually fill out that book while we do them. Okay, let's go ahead and get started on page 403. We are again going to be working with some triangles here. Hopefully that is in focus for you. I will make sure. I'm just going to press this button here. Let's make sure it's focused. Okay. Here, a little definition for you. The base and height of a triangle. Any side of a triangle can be the base of a triangle. They're saying any side of it can be the base. For each base, though, the height is a line segment or the measure of a line segment that begins at the vertex opposite the base and forms a right angle with the base. I'm a math teacher, and after reading that, it's about as clear as mud. What they're trying to tell you is any triangle that you have. Let's say you have this triangle here. Call it R, G, M, whatever you want. They're saying this could be the base, that could be the base, and that could be the base. But the base has to be a right angle, also known as perpendicular. Your base and your height have to form a 90-degree angle, okay? They have to form a 90-degree angle. And as you can see, there are no 90-degree angles within this triangle. Think of a 90-degree angle as something simple as a Post-it note, okay? Very easy. You'll notice that these two corners form a 90-degree angle. It goes here and turns a 90-degree corner. Okay, think of a four-way stop. If you're driving in a car, you come up to an intersection, you could go right, you could go straight, you could go left. These are perpendicular with each other. They form a 90-degree angle. So none of these are at 90 degrees, so we are going to make one 90 degrees. That's what we're saying in this one. So the base they're saying this one is side AB. So let's say that the side AB is the base. Let's say that this side, I'm going to draw a little bit heavier so you can maybe see it. They're saying this is the base. Okay. Well, if that's the base, and I'm looking for a height. Now, the height has to be perpendicular or 90 degrees, form a right angle. Well, if I look at that angle, that's not 90 degrees. I look at that angle, that's not 90 degrees. So we're going to make one. We go from this one up to the other vertex, C. Notice how it's dotted. That means it's not really there, but we're going to draw it in there. And now that's drawn in, so it makes this 90-degree angle. And now this here, that becomes the new height. So we have a base and we have a height. We need to know base and height, of course, to find area of a triangle. And to find area, you multiply base times height divided by 2, or 1/2 base times height. But your base and height have to form a right angle, that 90-degree angle. We have to make that 90-degree angle. Okay, look at the next one. It says the base is side BC. Okay, let's say that this is now the base. Well, if that's the base, I need a height. But again, that's not 90 degrees. That's not 90 degrees. We want to make a 90-degree angle or a right angle. So we're going to extend. We're going to pretend that this line extends this way, and then I could extend down this way. This makes a 90-degree angle between my base and my height, which is now right there. My base. Now, this is not included with this. This is still just the base, or small b, sorry, small b, base. This is just showing you we're going to extend it. We're going to extend that, and this becomes your height. Now we can take that measurement times that measurement and divide by 2 to find the area of the triangle. How about this one? The base is now side AC. Now we're going to say this is the base, AC. But again, to find height, I have to have a right angle. Again, 90 degrees. I don't have one. That's not one, and that's not one. So again, let's extend it this way, which now gives me to extend it that way 90 degrees. If you have a sticky note at your house anything, a piece of paper. You could check. Well, it's like, well, that's not 90 degrees no matter how I'm laying it on this triangle. This line will not give me a 90 degree, but if I put it right here, notice how the line that they have there dotted, that and that form that 90 degree angle that we're talking about. Over here, if I extend that line and I extend that one down, that one formed the right angle we're looking for. And again, now this one, take this one this way, you take a look, this is our base, that's our height. Those two formed that right angle, the 90 degree angle we're talking about. Okay, that's what we're trying to find. How are the three heights for triangle ABC the same? Well, let's see. How are the three heights for triangle ABC the same? Do you think they're the same? How are they the same? Are they talking measurement? Well, because I'm looking, and this looks a lot smaller than that. This one seems to be in the middle. So are they the same length? I would say no. But the three heights are the same because they all form a right angle with the base. That's how they're the same. They all form a right angle with the base. That's what we're trying. That's how they're the same. How are the three heights for triangle ABC different? Well, we just explained that. They all have different measures. They all have different measures. And that doesn't matter because you look at this base was really long. The height was short. This time the base is kind of, I'd say, a medium, and the height's more of a medium. And now this one, the base is kind of short, but the height was very tall. So it all would work out to the same exact area. We're just using the different numbers that work with that. So it's kind of cool how triangles actually work. Let's go ahead and use this in a couple examples. Next page, we should be on page 403 now. 403 in the bottom of it, it looks like. It says, draw the height from vertex N. So now they want me to draw a height from vertex N. So again, if you have that little sticky note or anything at your house, you could even tear a corner of your book off. As long as you use the actual straight corner of your book, you could use that. So I want to form a height from vertex N. Well, if you look, this one and that one here is my vertex where they meet right there. Well, that's not forming 90 degrees. That is not forming 90 degrees. So I want to form a 90 degrees. Let's form it on this line somewhere. So if I were to actually take the sticky note and kind of go along this line, look for when that point of my sticky note ends up meeting in that corner. So I'm kind of going down and bam, there it is. You can see how I'm straight in line with that right there. And now if I hold that, does that form an 90 degree angle right there? No, that wasn't quite it. So maybe, what if I hold it on this line here? And now I'm going to go along this line until I line up with that vertex. So I go along, bam, there it is. You can take a look, see how my sticky note is right along the bottom right there. And now, what if I drew this line right there? Now, this should be dotted and then right there. Now that forms that 90 degree angle, also known as a right angle. Okay. Now this becomes your height. This is the height of the triangle. This would then be the base of the triangle. So the base side is where your height landed on. So this is your base. We can call that side ML. You could have also called that side LM. Doesn't matter which order you go. So either way for that one. Take a look at the next one, number 18. It says, draw the height from vertex M. So now I want to draw a height from vertex M. Well, let's see. I want this to connect up with one of these sides at a 90 degree angle. So if I extended this side right there, where do you think that height would end up? Because again, if the base is always on the opposite side, let's look. If I were to make this down here on that line, I'm kind of going along. It's not lining up with that vertex up there yet, kind of going along. And there it goes, where you can see the bottom of that sticky note is along the bottom of that triangle. I'm almost to M, a little bit more, and there it is right there. So now if I were to draw this little dash line right there, You can see how this extends, but what do you think I have to do here? I also have to do a dotted line. Now this, again, this forms that perpendicular or a right angle from my vertex M all the way down to my base down here. So if this is the height, what side is the base on? Well, the height and the base have to form a 90-degree angle, so you could call it side LN. You could also call it NL. And one more here. Draw the height from vertex L. Well, now I want this one to find a height. Well, it looks kind of close to 90 right there, but it's not quite. You could check that by going along the line and seeing that, oh, yeah, that's not 90 degrees. If I go right there, that is not forming 90 degrees. I want to go from M onto this side somewhere where it's going to be 90 degrees. So if I take the sticky note again, I'm trying to get my hands not in the way of the camera. And now I'm going to take this and kind of go along, going along. We have to keep going until this side lines up with side that vertex L over there. And there it is. You see how close I am right there? This side was right along that side right there. So basically, you can do without a sticky note by, okay, I know it's going to be down here. What if I extended this over to here? And I extend this down there. Now, that forms that 90-degree angle. Looks kind of funny. I realize that's not even on the shape. Like this one's not even on the shape. But that's how tall the shape is because you have to have a height that is perpendicular to your base. So this would be our height, and our base would then be what? How about Abe? What would be our base? Yes, Minnesota, MN. Or I spells NM. Was that New Mexico? Something like that. So you can see height, base. Sometimes those are going to end up off your shape. Sometimes you could do them on the shape if you do from that one. Okay, next page. Find the area of each triangle. So now we're going to take what we just learned and we're going to use it and apply it to finding the area. If you're going to carpet something or paint something, it's the area of a triangle, this will be very useful for you. So we have this triangle here, a lot of numbers, a lot of measurements in there. I see 4 different numbers. Well, how do you know what to use? Well, we just talked about it. We know that area of a triangle is equal to 1/2 base times height. And order doesn't matter. Now, we talked about in the last lesson, previous ones, that you could take half of one of the numbers and take it half as height. You could multiply that base and the height and then take half of that, divide by 2. Any way that you seem fit that you like to use. Well, what's our base and what's our height? Well, let's see. These two have to form a 90-degree angle, right? They have to form that 90-degree angle, or they have to be perpendicular. So I see a 17, I see a 10, I see a 9. Well, this is a key. Look for that right there. That's going to tell you that's the 90-degree angle. We're going to use what is connecting those two. Well, the 8 is right next to it, so that's your height. Well, what's connected to that 8? Way over here. This would then be your base. So we have 1/2 my base, 9, times my height, h. Well, 9 times 8 is 72. Half of 72 is 36. This would be centimeters. Now, again, we're working with area. Area is 2-dimensional, so centimeters squared. Now, what if you said, I want to take half of one of the numbers? Well, half of 8 is 4. 4 times 9 is still 36. Doesn't really matter. How about the middle one here, the purple triangle? Again, 4 numbers. But our base and our height have to form that perpendicular line. They have to be 90 degrees. Again, look for that. That's kind of your key. Oh, I found it right there. Now, that's formed from the bottom one, the 18, and the one going next to it, the 12. So I'm going to use the 18 and the 12. So my area is equal to 1/2 18 times 12. Now, let's make the math easy. What's half of 18? 9. 9 times 12, that's one of your math facts. You should know that 9 times 12 is what? 108. I did hear somebody say 108 what though? 108 what? Measuring in centimeters. We're dealing with area, so centimeters squared. You got it. Centimeters squared. Circle that answer. Next one, this peach kind of color. We have 4 numbers again. What are we looking for? What should we be looking for? How about, let's go with Kari. What am I looking for? What's the key that we're looking for? Yeah, we're looking for that right there. That's the key. That's going to tell you what the base and the height are. So you say, okay, that one's connecting my 4. It's connecting my 6. So it's 1/2 4 times 6. So I'm going to take half of 4 times 6. You could also put in parentheses if you want to. We don't really have to. Just 1/2. Oh, 1/2 times my 4 times my 6. Any order. You could take 6 times 4 is 24. Half of 24 is 12. I could take half of 4, which is 2. 2 times 6 is still 12. You take half of 6, 3. 3 times 4 is still 12. It all works the same. 12 centimeters what? Squared. There it is. So the actual math is easy. Just make sure you find your base and your height. Look for that box right there. Makes it saying, oh, these two are 9 degrees. Just basically telling you to focus right there. Bottom here. Jared wants to carpet his triangular part of his basement floor. How much carpet will he use? Okay. Again, 4 numbers. What are we going to focus on? What should I be looking for? How about, let's go with Eli. What am I looking for? Yes, that. We're looking for that thing right there. Focus in on that. That's going to say, here's my base, and here's my height, dotted line. So it just says, how much carpet we use? Well, I have to take 1/2 of my 12 times my 8. Again, simple math. Maybe you want to take half of 12 and get 6. 6 times 8 is 48. So we have 48 what? Yards squared. It's area, yards squared. 48 square yards. Okay, good. Next page. It's the last page. Lucky you. Lucky you. Okay. Rona drew a pattern for a sail, for a miniature sailboat. How much cloth will she need to make 4 sails using this pattern? I'm going to circle number 4 so I don't forget later we're making 4 of these. Well, this one's pretty easy. They only gave you 2 numbers and they gave you the dotted line. They're making you focus right there. I know I'm going to take 1/2 of my base 4 times my height 9. Half of 4 is 2. 2 times 9 is 18. But I'm not making one of them. How many am I making? 4. So I'm going to use this pattern 4 times. So I have 4 18s. So it's 18 times 4. Okay, 4 times 8, 32. 4, 5, 6, 7, 72. 72 inches squared. And some of you might have said, I found that way before you, Mr. Tweeten. I knew that we were going to have 4 of them, so I didn't take half of it, and I just ended up taking this number, and I doubled it. Yeah, that's fine. If you understand that, you're ahead of me by far. Feel free. If you understood that, go for it. Babette, baby T, Babette. I'm just going to call her Baby T. I'm going to pretend like she's some kind of rap star. Baby T wants to paint this triangular portion of her bedroom wall purple. What is the area of the space she needs to paint? All right, Baby T is going to paint it purple. It's going to look pretty fancy if you ask me. And I see 2 numbers. I see some dotted lines, and there it is. I'm focusing, I'm finding that. That tells me that's my height. There's my base. So again, I have 1/2 of my base. 8 times the height, 5. Half of 8 is 4. 4 times 5 would be 20, right? 20 what though? Dealing with feet, area squared. So Baby T needs to paint 20 square feet or feet squared. A gallon of paint, I think, roughly covers about, what, 300 square feet? So not a lot of paint to paint that little triangle in her room. Maybe just get a little quart jar. Explain how finding the area of a triangle is related to finding the area of a parallelogram. Well, little vocab. What was a parallelogram? Yes, your parallelogram had opposite sides that were parallel. So if you take a look, like this example, let's just say this is your parallelogram right there, right? Now, if I say that this was 12 and this was 7, can I find the area of that parallelogram? No. They needed to give you that right there, which would form that 90-degree angle. They need to give you the height, because remember, it's like taking this shape and moving it over there and putting it on there, and what you would end up getting is a rectangle, but that height would now be perpendicular, forming the right angle, which is what they would give you. So it's similar in that fashion right there. I appreciate you tuning in today. Thank you. If you have any questions, feel free to reach out to me or any one of the other awesome, fantastic 5th grade teachers, and we will see you next time. Thanks for tuning in. Take care. Have a great day.